Today we're going to look at a couple methods to solve quadratics. We're going to use square roots and completing the square. So let's get started. We're going to look at using square roots first. So as we go through this, we're going to make sure that we get the x squared isolated first. So our first step is going to be to add 32 to both sides here. And we're going to get 9x squared equals 32. This stage we want to divide by 9. Again, we're trying to get x squared isolated. So we have x squared equals 32 over 9. Okay, at this stage, what we want to do is we want to take the square root of both sides to get rid of the squared with the x. So we're going to square root the left and square root the right. And remember, for square roots, when we're dividing on the right side of this equation, we can actually split this into two parts. So we're going to get x equals, now don't forget your plus minus, plus minus there, and we have the square root of 32 over the square root of 9. And the reason we split that, as you can see, is the square root of 9 works out nice and even. It's going to be plus or minus 3. Okay, so we got x equals plus or minus 3 down here, and then we've got the 32. Now remember, the 32 breaks up as the square root of 16 times the square root of 2. And of course, our square root of 16 is going to be 4, and we still have a square root of 2 left there. And at this stage, we're done. X equals plus or minus 4 square roots of 2 over 3. Okay, our next example is a little more lengthy, but not bad. So again, we're trying to isolate the squared part. This time we have something inside the parentheses, x plus 4. So we're going to start with the same step. We're going to get our constant out of the way over here. So we're going to add 25 to both sides. And what we're left with is x plus 4 squared equals 25. Of course, just like on the last problem, when we're trying to get rid of a square, what we're going to do is we're going to square root both sides. And so the square root of x plus 4 squared is just x plus 4. Don't forget on the right side, your plus or minus 5. Now at this stage, what I tell students to do is to split this into two equations. When you get down to this plus minus, it's a lot easier when we have something complicated on the left, where we're going to split it into two parts. So we're going to use the positive part. So we have x plus 4 equals positive 5. And then our second equation is going to be x plus 4 equals negative 5. And so what we've done is we've handled the plus minus part here by splitting into two parts. Now we have two simple linear equations to solve. Our first one is going to yield x equals 1 as a solution. And our second one is going to be x equals negative 9. Okay, our next task is to use a different method for solving the quadratic, and it's called completing the square. I want to back up just for a second. Let's go back and look at our last two examples. What we notice here on the first, especially focus on this piece right here. So notice here there is no bx term. So that allows us to use taking square roots, because we can square root the x squared. If there was an x there, when we go to square root, we'd have quite a problem. So let me just kind of illustrate that real quick. So if there were an x there, and I were to add my 32 over here, when I go to square root this side, notice this does not simplify. So just on a note here, taking square roots only works when we don't have a bx term, or when we have it formed like this, where we have a parenthesis squared and just a number over here. Because certainly we will get a bx term out of this when we go to multiply this. We think about this like this, x plus 4 and x plus 4. Of course, we're going to get a 4x and a 4x, which is going to give us a, that's an x, not an 8. It's going to give us an 8x as a middle term, but it is already formed in a way that we can take square roots. So just on that little side note, make sure you know when you can use taking square roots. And when we get here, we're completing the square. Notice we do have a bx term. Certainly we could use quadratic formula. One of the benefits of completing the square is to get it in vertex form, as we'll see as we go along through this video here. Okay, so completing the square, here's how it works. Our first step is going to be to divide by the leading coefficient to get x squared by itself. So notice in this case, back it up there, get a pen. Okay, in this case we have an x squared here, and that's what we want. If you already have x squared there, that's okay. You can just skip this first step. Okay, but if you have a number next to x squared other than 1, make sure you are following this first step. Divide by the leading coefficient to get just x squared. So I've divided everything by 2 in this case. Okay, step 2. What we're going to do is we're going to take half the b value and square that and add it to each side. So what does that look like? Well, the b value in this case is 4. So we take half of that, and of course half of 4 is 2, and then we square that to get the value that we're going to add to each side. Notice that's what we've done here. Okay, and the reason we've done that is we want this side over here to factor really nicely. And by the fact that we've taken half the b and squared it and added to each side, allows us to factor it super easy every time. So we'll take a look at that here. So go along. Okay, so at this stage we're down to step 3. So on the blue step we've added 4 to each side because that's half the b squared. And now we're going to reform and factor the left side. This side over here factors nice, like this right here. Okay, it's always going to be a perfect square trinomial because that's how we built it. We took half the b and added that and squared it and added it to both sides. Okay, so now that we have it at this stage 3, I'm going to switch slides here so we have a little more room. Okay, and we're going to look at what we do next. Okay, now next, notice this looks a lot like what we started with completing the square. Before we go there, though, I just want to show you the benefit of completing the square because sometimes that gets lost in the teaching. Okay, the benefit of completing the square is a lot of times is to write the equation in vertex form. So notice if I now subtract my 15/2 back over here and set it equal to 0, now I have a quadratic equation in vertex form. So that's one of the benefits of completing the square. You see this happen with equations of circles. Now, just on a note here, how do we identify the vertex? Remember, this is left 2 from the origin, and this is down 15/2. So this would be our vertex. And now we can just look at the equation and identify the vertex. Okay, but our main goal here is to solve. So what we're going to do is go ahead and finish that off. So remember our stage. We're going to square root both sides. And we're going to get x plus 2 on the left. And make sure you put the plus minus here. And we have the plus minus of square root of 15 over the square root of 2. Okay. Now at this stage, I would suggest going ahead and simplifying your radical. Remember, we don't like square roots in denominators. So we're going to go ahead and take care of that now. We'll call this rationalized in a denominator. Okay, so I'm just going to bring down my x plus 2 equals plus or minus. And up top, we get square root of 30. And down below, we get 2, because square root of 2 times the square root of 2 is 2. All right, and again, just like we did before, when we get to this plus minus, and we have something on the left side that we have to deal with, we're going to split into 2 equations. So we have x plus 2 equals positive square root of 30 over 2. And we have x plus 2 equals negative square root of 30 over 2. And of course, to solve, we're just going to subtract 2 from both sides. One way you can write this solution is x equals plus or minus the square root of 30 over 2. And then we're subtracting 2 to get this plus 2 back over there. So this would be our final solution. If you want to split it into 2 parts, you can do that. You can also turn this into a decimal if you want. You can just type it in your calculator. And then you could check on the x-axis to figure out where the x-intercepts are. So that concludes taking square roots and completing the square. Hope that goes well for you.